Hi everyone, my name is Aditya and I'm going to tell you about the atomic force microscope. It is one of the most pioneering technologies in our current era and it is one of the best in the industry. So one must wonder what an atomic force microscope actually is. The atomic force microscope is a high resolution scanning probe microscope. That is a resolution you can measure in fractions of a nanometer. So what it actually does is it measures the local properties such as the height, friction, magnetism with a probe. To acquire an image, to put it in simple words, it probes over a small area of the sample, measuring the local properties simultaneously. Now, how does it actually work? The AFMs operate by measuring force between the probe and the sample, the probe and the sample, and the probe is a sharp tip with 3 to 6 micrometer tall pyramid and 15 to 40 nanometer in radius. To put it scientifically, the working can be explained by generally measuring the vertical and lateral deflection of the cantilever by using the optical lever. The optical lever operates by reflecting a laser beam off the cantilever. The reflected laser beam strikes a photosensitive photodetector consisting of a 4-segment photodetector. To put it simply, the laser beam strikes a ray of light and it reflects back to the photosensitive detector. According to the topography of the surface, the cantilever moves because of which the tip moves. And in accordance to that, the light sensitive photodetector gets light in various positions, determining the various parameters by which the topography is affected. Now, when we talk about the applications, it is most usually for imagining surface topography by recording the position of the sample relative to the tip. Much uses include surface manipulation using tip forces and to measure the forces between a sample and the probe. Whereas other industries in which it is used is semiconductor science and technology, thin film and science and technology, tribology, that is the surface and force interactions, surface chemistry, and polymer chemistry and physics. When we talk about the modes of operation, there are two modes basically, contact mode and non-contact mode. In contact mode, the cantilever drags across the sample and it uses the deflection of the cantilever to measure the contours of the surface. When you talk about the non-contact mode, the tip vibrates slightly above the resonance frequency and does not contact the surface of the sample. But one must consider that like forces such as van der Waals forces decrease the resonant frequency of the cantilever. So we must keep that in mind and look into it with the help of a feedback loop system which helps to maintain the oscillation amplitude constant by changing the distance from the tip to the sample. Now to give a pictorial representation, the contact mode in which the cantilever probe touches the surface of the topography and non-contact mode in which there is a definite gap between the surface and the cantilever, and the tapping mode which can be said to be a combination of both the contact mode and the non-contact mode. Now, when you talk about the precision of the atomic force microscope, it is scanning probe microscope. So, it is demonstrated to have a resolution of fractions of nanometer. That is more than 1000 times the optical diffraction limit. Information is gathered by feeling or touching the surface with a mechanical probe, as I explained earlier. When we talk about the advantages, it has various number of advantages compared to the next competitor it has, that is the scanning electron microscope. AFM can be used in a variety of environments such as encompassing ambient, liquid and vacuum. It is suited for analysis of biological samples also. AFM can use for both scanning and electron microscope. Sorry, AFM can be used for imaging both conductive and non-conductive samples, unlike the various other methods like SEM. AFM depends on the sharpness of the tip. Tip of the AFM can be produced according to a much smaller size than the nearest competitor, that is the SEM. So the smaller the size of the tip, the better the resolution. Now, when we talk about the AFM, when compared to the SEM, it can produce a three-dimensional image of the sample surface with quantification of the surface roughness, while only two dimensions can be produced in the SEM. Lastly, adaptations can help to form the chemical makeup, conductivity, electric field, magnetic structure, elasticity, and work function of the sample surface. Whereas in SEM, only the chemical makeup can be ascertained. Now, when we talk about the major manufacturers, these are all in the US, Arizona, Wisconsin, Dallas, Texas, and these are Brunker Nanosurfaces, Mad City Lab Incorporated, Hitachi High Technologies, one in England where it is known as Nanomagnetics Instruments, NanoSurf AG Inlet Cell, Switzerland. Now, when we talk about the pricing aspects, each AFM has a different price, and this has been due to the various aspects and the parameters which it is made according to. Various aspects are type of scanner, sample size and weight, scan range, lateral resolution, vertical noise level, low noise levels of the deflection signal, for example, for sensitive photospectroscopy, controller performance, elaborate accessories, temperature and environment control, special measurement modes. When we talk about the average price in an Indian market, it starts from 5,50,000 and it can go up to $100,000 in the US market. So that's it. Thank you for listening.